Good evening, class, and welcome to the Week 2 Max tutorial. So this is the patch that we built in the first tutorial, and as I mentioned in class today, on my version of Max it worked perfectly fine. But of course, we've had a recent update in Max, and unfortunately we cannot use this object anymore. It creates a whole run of errors every frame. And of course, what's happening here is, if I just break this connection, is that all of these Visi abstractions have been updated in this latest version of Max to all be processed on the GPU. And I didn't see it straight away when a couple of you sent your patch to me to fix, but you can see here the color of this line called a patch chord coming from our jitter matrix format. It has the color green, and then as it exits the first Visi plugin, it has the color blue. Now just watch out for these blue patch chords throughout the semester, because what they indicate is that this processing here is happening on the GPU and not in the main CPU context of the computer. It's good news for us because it means we should get awesome performance out of these abstractions. But the first thing we've got to do is just get our patch visible. And to do that, I'm going to introduce you to another object. So if we go up here to the menu and click and drag an object down onto the space, we'll notice that the cursor is flashing in there. And I want you to type JIT for jitter, full stop, and world. Jitter has predictive text as well, so that the area there in blue you can leave alone. Now all we have to do to make this work now is grab this object called a toggle box, and then we have to connect the video stream to this and turn it on, and you'll see the JIT world object processes also on the GPU. And if we click on this window here and hit your escape key, you should be able to go into full screen mode and drop out of full screen mode. This JIT world object is, it's an advanced object. I was planning to roll this out in a few more weeks because it has a lot of features and there's a lot of things that it can actually do. It's also a render farm in itself. So the toggle box here activates, it has all of this kind of programming mechanism up the top here. And you'll find that this little chunk of programming, which sends out a clock pulse to drive the video frames, is now redundant in the program. We can still use these message boxes here, and remember that a message box doesn't have a border around it. Messages are commands, instructions that objects understand. So anyway, that should get your program going. And you can see here that I've included feedback and a resampler. And I've included another object as well that allows you to animate parameters. And you can have a lot of fun with those. So we have grey connections here, and these carry data, typically control signals. And there's a whole bunch of different things in computing, different ways we look at numbers and so on and so forth. And I'd like to introduce you to some of those in today's tutorial. So we can build on the side of this, and you can see I've just cleared my Max console. If you want this console to appear on the side of your programming window, it's a great idea. And you get to it by using this command here, Command M. We'll activate it and make it disappear. And the console is your friend. It's a dialogue that you have with the Max language. It will show up errors and things in there. So yeah, get used to keeping that open. You can also access it as a floating window as well that you might want to keep behind. And if you want to clear the messages in that window, you just hit that little cross down there, which is good for your debugging process of your code. So I'm just going to open my patch by clicking on the empty space in the window here, and you'll see this little padlock is opening and closing. I'm going to select all, and I'm going to move all of this code over to the side. I'm going to keep it there. But let's just have a look at some of these things. I want to grab this toggle box first and pull that out on the screen. And I want to grab this box with a circle in it that's called a button. And I want to grab a number box here. And you can see if I click first of all on this, it will bring up a little menu down there. There are 3 different types of number boxes. And we'll be exploring the first 2 today. So let's click this one. This is called number and I for integer. And if we have a look here, let's connect this toggle up and then lock your patch. And if we click in there, we'll see that when the cross is activated, the toggle box outputs an integer value of 1. And when we click it again, it outputs an integer value of 0. And this is, you know, a very, very basic computer program that we've just made here, but one that is incredibly useful and incredibly necessary. All of these things here respond to those values as well. So I can click in this bar here and turn something on and off. I can also hover my mouse around and look at what these inputs do. Video input, saturation, the Visi plugins will always accept an integer value going into this video input as well. And if you send them a 0 or a 1, you can turn them off. They won't accept any other types of values. If we have a look here at this button, connect that to your number box, and if you lock your patch and you click in here, you'll see that nothing's coming through. This is a different type of interaction in Macs. It's called in computing a trigger, and a trigger sends out a magic kind of pulse of information that will say to another object or a message box that it's connected to do it, to activate it. So let's just have a look now at a message box up here. Next to the object we have a message. And you can type things into these message boxes. Objects have their own messages that they understand that have been created by the developers and programmers of the objects themselves. More about that later, but you can see the JIT movie object understands the message to read. And by clicking on this, you will load a media file into that object ready to play. But what I want to do is just a really basic message and put an integer in there of 1. Then I'm going to click and drag over those objects, copy them, and modify. And join them up to this integer box here, which we're using kind of as a display of what we're doing here with this program. So you'll see now if I click in this button, it will send a trigger into this message box and send the message box on, and we'll get an output there. Similarly, if we click here, it will send a 0. So this is a handy piece of code. It might seem at first glance to be incredibly basic and simple, and yes, it is. But nonetheless, welcome to these objects. The other box that we have up here in the menu is called the comment box, and this is another very basic thing but very useful. And we can click here on the screen and we can drag this down, and we can write write words and instructions and things in there. These are passive things. They don't become part of the program in itself. They don't execute any commands or interact with any of the objects. They're there purely for you to write your own instructions and commentary, and so that you know what these things are. So I'm going to write in here, this is a toggle object, and it outputs a 0 or a 1, or it's integer based, and that's kind of the shorthand for Macs. This is a button object. This will help you remember if you write these things in. And it outputs what Max calls a bang or a trigger. And triggers in Macs are really important for timing and things. And you'll find that messages require triggers to execute them, and your programs will have these things in them. moving on here, we've got a whole bunch of visual objects, very handy. So let's grab the slider and pull that out. And let's connect that to a number box. And when we lock our patch, we can move this and get a sliding value of a particular range. And this is a very useful object as well. At the moment it has a fixed range of 0 to 127. That's 128 steps in the data. We can change that by going to the inspector here, and any object that is selected, if I bring up this inspector pane, it will bring up a whole lot of values and things here that we can use to configure the object. And you'll see right down here the value of the object, the range is given there, which we could change to another value, like twice that size, 256. And then when we lock the patch and move the slider, you'll see that it has more steps in it. It goes up to 255, and you might say, well, didn't we put a range in of 256? Yes, we did. But it starts counting from 0, which is a step in itself. So 256 steps, 0 to 255. I didn't click and drag that comment out from the menu. I just pressed C. So try that now, a little shortcut. Just press the letter C and your comment box will appear. So this is a slider object with an integer range of 0 to 255, or 256 steps in all. So over time you'll get used to using these things. And having introduced you now to integers, which are whole numbers, like 1, 2, 3, 4, 5, but they also include, as a family of numbers, the negative numbers. So -1, -2, -3, they're all integers as well. And integers are fabulous things for counting. Apples, oranges, all these sorts of things. And in fact, in Max, there's an object called a counter. And we can give that counter a range of 0 to 255. And counter is looking for one of these button objects, these trigger things. And you can see here, if I start triggering it, off it will go, slowly counting up and down. Well, it's mainly going to go up and then it will reset and go up again. So integers are great for that. If I want that to count automatically, I can use an object called a metro, which is a little clock timer. And I can say every 100 milliseconds, or a tenth of a second, send out a trigger and start this object counting. So it's not fair when you're looking at one of these tutorials, you know, Stu, how did you learn that? How did you get that down? How did you work out these little things in Max? Well, it's taken some time for me to do that. But I have gleaned a lot of these things from the basic tutorials that are provided by the software. And if we go to the help menu and we hit the reference link, and you should have a page like this. If you don't, hit the little house or home button and go to the jitter tutorials, which is where we began last time. And if I click on tutorial 4, there's my lesson. I can open the tutorial, which is a very complicated looking tutorial. And this tutorial allows you to do looping of movies and stuff. It's quite complicated, and it has a lot of things that are going on in it. But at the same time, you can copy all of that, put it into a new patch, and start messing around with it and understanding how it works. And turn the volume down here, or change the rate of the video, which is maybe the sorts of things that you want to do, or maybe not. It also introduces some other objects here, like a route object, and shows you that all of the messages that some extra messages that you can use to run your movie objects. So you may want to borrow some of this programming, and let's say maybe just this much, and you can feel free to copy that and put it into your own patch. And we should be able to see our window here. And I might just have to turn this one off, turn the color on. And you can see, if I turn the kaleidoscope off, you'll see the countdown timer going there, which we can now slow right down or speed up with this rate control. This is a cool thing that messages do. This message box has a $sign and the integer 1 there, and what this means is this changing number coming in at the top here will be joined to this message. Message boxes can also be used as displays. If you put a patch cord into the top left inlet, you can see the combined message and use them to debug your software. But anyway, you don't have to worry too much about all of those ins and outs. That will come to you in a few more weeks of practice. But right now, I'd like to maybe take this moment to introduce you to what I think is one of the most important rules of development. And if we think about these as Stu's laws, the first law I would like you to learn is copy, paste, and modify. Okay, so this is a great way to learn how to develop. And you might say, oh, shock horror, what about Turnitin and all of the written work and everything that we do as students, doesn't that have to be, you can't copy that. But here we're learning a language from scratch, and of course I expect you to copy these things, put them into your programs, and then mess with them. So copy, paste, and modify will be 90% of your development journey for the first 500 to 1,000 hours as a developer. And that's a given. It won't be until you've been developing for 2 to 3 years before you actually come up with something that is totally original and making a contribution back to the development language or the community. And that's expected of you too. But the way to get there is to copy, paste, modify. So in your briefs this semester, a lot of the code that you will use will be copied from the tutorials, from the examples in the help menu, and from elsewhere on the internet from your own research into Max. And maybe it's appropriate to look at the second law, Stu's second law of programming. So if 90% is copy, pasted, and modified, that will take 10% of the time. And the other 90% of the time will be getting your own little bit of original code to work in your program. And that's not unusual either. So 90% of the work is a breeze. 10% of the work is hard work and sweat. And it takes 90% of the time to do that when we're programming. If we go to the module for this workshop, you'll see that there are a couple of Max patches that I've prepared. So just download the first one and save it somewhere, and with the second one as well. So I've already done that, and then open them up. And the first one here, and I'm just going to turn off this other patch, but I'm going to leave it there. We read the countdown movie and we press play. You'll see here there's an overview of all of the Visi objects, and I've laid them all out in a very low resolution video, so you can play with them all and see what they all do. So feeder we looked at in class, which creates feedback, feed forward. Fogger, there's an embosser. There's a sketcher, which sketching and solarizing, they're similar to those Photoshop effects, and tracing as well. These are a kind of rudimentary video processors that we use to do feature extraction with, not dissimilar. So even though we're just looking at them in a context of messing around and creating colorful effects, they're actually based on kind of computing methods that can be useful for extracting data. So just have a look at these and play around with them. You might see some things there you like. And at the start, there's a two-toner kind of effects here. Now, I've only put one kind of black and white movie in there, but we could modify this and create another message box with read chickens.mp4, which is another common video that's used in the tutorials. And you could run some rasterized video into all of these plugins and see what they do. And you'll see some really cool and interesting things when you do this. So two-toner, brightness, contrast, and saturation. An object called a delayer, which does kind of weird blending effects. creating interesting ghost images. There are objects here for granulating the screen up. And the downsampler effect, there's a whole range of things that you can do like this with video processing in Max that can be really beautiful for interior design projections. So tiling up the screen and whatever, you can make textures that are suitable for projection onto walls and so on. There's another one here, one called a pixelator. And, you can get quite a lot of interesting effects out of that. Resampler. The plane mapper is a little bit more abstract, and it allows you to reorder the planes. So RGB, RGG, RBB. So it's very unusual, as is this multi 8R object as well. If you want to see the color, the true color of the video, then I suggest you use your two-tone effect. It's basically what you're doing with that effect is you're setting two ends of a histogram process. So I'm setting my black channel here, and I can say, okay, I want the black to be red. And similarly with the white channel, or I can invert the image like so and create a color negative image. But maybe just set them like that, and then you can experience what all these different processes do. And in Max, I must say that there are hundreds and hundreds of video processors. The Visi ones are great to learn first. They give you kind of a stock of video processors, and you can chain them together and make a whole range of really, really interesting effects. Especially if you use the kind of blending effects. There's one in here that I'm not sure if I haven't put in there, which is called a slider. Anyway, please play with that this week and have a look. There won't be too much Max homework this week. It's more about having a play, having an explore. If you can spend an hour or two, just do this tutorial, that would be great. Keep the momentum going. But I would also like you mainly to focus on your ideas and use these things to help inform you as to what kind of video things you can actually create. Now the other program there that I made is a summary of all the transformation objects, and I'm just going to read another movie called Dishes, and set the color to normal. So you've already met this kaleidoscope chap, and there's a fractalizer. We can put a color tint on, or we can turn it off. And there's a rotator. Just lets you move the video around. And you can see it's in a wrapping mode here, so you can have it in a mode where it's mirror imaged, kind of folded, or I'm not sure. Yeah, I can just see it down there in the corner. Might just turn this off. You can see it's kind of rotating around. We'll have to pull it back to the middle of the screen, I think. Yeah, that's it. And the scrambler does some very interesting things. It cuts the video into different slices and then shuffles them like a deck of cards. Zoom gives you a zoom mode, and it's in, at the moment, a negative value. Positive value, negative value gives you an inverted image. Upside down and left to right inverted. This Visi object, the oscillator, is a generator, and you can see that it's outputting some values here. This is like a number box. It's called a flow number box. Flow for floating point. So before when we looked at that slider, we had a number of steps in that slider. Well, the floating number ranges have many steps in them. Thousands. 65,000 for a 16-bit. A 32-bit number would be 65,356 squared as a number of steps. And we don't call that value an integer. We call that a floating point range, and we would call that a long. Literally the word long. There's long 32, long 64 on our computers. And so there's a lot more finesse and fine tuning with floating point number ranges. But of course, you can't see them with an integer box. You must use this floating number box. And all of these objects here, they output floating point ranges, which are typically always given as a range of 0 to 1 in computing. Very rarely will you get a floating point number range which will go beyond 1, because it's not really about how big the number is. The floating point ranges are always about how many steps are there in the data between 0 and 1. The more steps we have in there, the more faithfully we can sample a color or a sound or something else from the world around us through senses. You can see here I've included another object so we can display this floating number point range. So at the top here we've got 1, and at the bottom here we've got 0, and you can see the actual steps in the data there. And here you can have a look at some of these simple waveforms. So this is called a ramp wave. And this is the opposite ramp wave. There's a triangle wave. A sine wave. And another wave called a sample and hold. And what sample and hold does is it's shorthand for creating kind of a pseudo-randomized range. And typically there's a type of noise pattern that is sampled at all of these time intervals to give you a randomized range. A sample and hold patterns are generated in lots of different ways in computing. So this week I'd like you to explore the the world of all these kind of rasterized processes using Visi, and focus on your presentations for next week. If you have any questions, or if you find anything in the tutorials that are not working for you or whatever, don't hesitate to contact me. But I've got the latest version, same version as you now, so I think we should be right for the rest of the semester. Anyway, thanks for tuning in, and I hope you enjoyed this week's tutorial. Thank you.